before we begin this demo, I wanted to put ourselves both in the shoes of the developer and IT operations. So as you can see, the developer, all they really care about is writing the code. Now, that's also a very important job too, because what the developers need to do is translate what the business is trying to ultimately achieve based on some of their strategic initiatives in which they have determined. That could either be writing new features to existing applications or writing a new application to satisfy some of their requirements that they have identified. Now, the IT operations staff has an equally important job too in regards to supporting that application workload and ensuring that it's going to be running in an environment that is very highly secure, highly available, but that it's also an environment that can be easily monitored against and that they can patch against it when necessary. So as you can see, they both have an equal share of important responsibilities to carry out. And so Pivotal Cloud Foundry is a framework in which provides that platform as a service that can validate that the code is going to run properly based on some of those requirements, that is going to run properly on the underlying infrastructure that has been determined they want their app to run in. That could either be an IaaS framework, that could be OpenStack, VMware, or AWS. But Pivotal Cloud Foundry would allow for that portability of that application workload to run against those environments. Now, as you can see, it can also be used as a tool to bridge the gap between the developer and operations and to be able to streamline the deployment of their code very efficiently. So for this demo, I'm actually using my subscription to Pivotal Web Services to use Cloud Foundry, but instead of having a local distribution of Pivotal Cloud Foundry that I need to manage, I can actually just subscribe to it to still use the Cloud Foundry framework to manage and deploy my apps, but I'm accessing it through my subscription. And as you can see, when I first log into the web interface, it gives me the command that I need to use to log into the environment that's associated to my account. And once I authenticate, then I need to sign into the org that is hosting my apps. And in this example, I'm actually going to be pushing a very simple app using the Python language that's going to assign me a globally unique identifier GUID when I access the app. And as you can see, this is the repo that is hosting my app in this directory, and this is the code for my app. And within this repo, there's also other files that are associated that define the requirements and the dependencies to my app that are necessary for my app to run. And what Cloud Foundry does is it reads that repository and validates that all the requirements and dependencies are satisfied so that it can push and deploy the app successfully. And so when I enter the simple command cf push and I name my app Nick Hello, I'm also giving it a memory restriction too, to only consume up to 128 meg of RAM. And so what this is doing is it's actually naming my app Nick Hello by using the Python code that I just showed you. And now it's going to be pushing that out so that it can be accessible through the internet. And now that my app has been successfully pushed, you can see it shows me the URL that can be used to access my app. Now, what I'm intending to do here is I have named my app and URL something that, say, isn't advertised to my customers, but I just want to test to ensure that the deployment of this app and code is going to work. Now, say that the app that I do have that is advertised to my customers is named My Simple App. Now I can still, within the same repo and using the same code, still deploy another instance of my application under a different namespace. So this shows you that you can, use the same code and repo to publish your app out into different namespaces or different environments. Say you want to push it out into a QA environment before it goes to production. This is demonstrating that capability. And so now, as you can see, my simple app has now been successfully pushed and published, and I got my unique identifier. It shows me my URL that I need to access the app. As you can see, the same code is pushed out in two different application instances under two different namespaces, and when I access them, I get two separate GUIDs. Now I have this more sophisticated app as well that just has pretty much the same code that you saw previously, but there's additional information to enhance my app, such as additional text, and I also have added a hit counter to this. And as you can see, the hit counter is, you can think of it as a data set. So that data set still needs to be used and associated to my app to store the hit counter information. And what I'm trying to do here is just trying to generate traffic on my app, because I'm also monitoring that app as well. So you can see I have three separate instances of my app, and the service that I have used to store my data set for the hit counter is a Redis cloud subscription service, which is a fully managed cloud service for hosting and running your data set in a highly available and scalable manner. Now, as we're looking through this marketplace here, these are also additional services in the Pivotal Web Services marketplace that you can subscribe to as well, that you can bind to your app and leverage these additional services. Now I can also issue a command called CF Marketplace as well and see all these advertised services. And as you can see with Redis Cloud, there's different subscription plans. And if you look, that asterisk are the paid for plans. The ones that don't have an asterisk is actually a free plan. So I'm going to create a service to that free plan and name my service My Simple App Service. Because what I'm trying to do here is now bind this service to My Simple App so that I can store that data set that I need for my app. And so as you can see, it also shows that the service has been successfully created, but it's not bound to any app instance right now. So in order to bind it, I can just issue this simple command called CF bind service, my simple app, so the app name and then the service name. And it binded the service to the app very quickly, just like that. And so when I do a refresh now, you can see that my bound apps has a count of 1. And you can also see that My Simple App, when I published it without defining the memory restrictions, it just published it with the default of 1 gig of RAM assigned to it. Now this proves that my service has been bound to it. So what we're trying to do here with the Solution Summit app that has the hit counter already associated to it is I'm also monitoring this app. I'm going to show you the Python code for this app. I'm also showing you the requirements here that I have to define, that I'm also using Redis and I'm also using New Relic to monitor my app. And you can see that they have also been defined in my Python code. Now, I can also, through the command line interface, analyze the environment for my app as well by doing a CF environment command. So with my app right now, it is has been published with only one instance. So I'm only getting one GUID every time I refresh and hit this page. But you can also see I'm monitoring this app in real time. And furthermore, it's also monitoring all the different elements of my app as well. It's monitoring how fast Redis is responding, the page and everything. And what I'm trying to show here is that I want to be able to scale my app out into 5 instances. And as you can see, just by issuing that simple command, it very quickly scaled my app out to 5 instances. Now what that will do is every time I hit refresh on this page and access my app, it's still maintaining my hit counts. But as you can see, it's going to give me a different GUID every time I hit the app And what this is demonstrating is that the scalability worked, but also it's doing a round robin across all the instances and giving me a different GUID each time I'm hitting that different instance. Now I also want to scale my app out to 10 instances. So I went ahead and do that, and as you can see, I'm going to eventually end up getting 10 different GUIDs. Now, as you can see also, when I was doing this, it actually reset the hit counter every time. So say another additional feature that I wanted to add to my app would be so that every time I scale it out or scale it down, that the hit counter will not reset. So as you can see from the presentation earlier, that every time I want to introduce a new feature through that feedback loop, this may be a feature that was identified in that feedback loop. So I may want to go ahead and incorporate this new feature so that my hit counter does not reset. Now, also, you can see here that this is where I have my app published in GitHub, and I am practicing continuous integration on my app. Every time I make a change to it, I'm using Travis CI to monitor those changes, and as every additional feature is being added to the app, it is tracking and monitoring that as well, so everybody has visibility into all the changes that are being made. So this demonstrates a continuous integration practice. Now, furthermore, as I'm monitoring my app, you can see how my app is responding within it, but also I can look at the environment and how that environment is responding as well. So what this demonstrates is think about how you can optimize not only your app and see how your app is responding, but as you move that app around and take advantage of the portability that Cloud Foundry gives you by being able to move your app out into different IaaS, underlying infrastructure environments. If you couple the monitoring of the app and how it's performing up the app stack, but then you can also monitor how the infrastructure is performing that is supporting that application workload, this can be very powerful to the DevOps teams to ensure that your app is not only going to be deployed out into the necessary environments that make sense to support that app workload, but then you can also start evaluating the cost of supporting and running the app as well to ensure that it's going to be in the most cost-effective environment.